Welcome everyone. This is the balenaHub virtual meetup number 3. Actually, the previous one was about Balena Sound, LoRaWAN, gateways, and this one, it's about home automation projects that we have on balenaHub that you can install in just few clicks or even less, and you will see other more advanced hacks during the next hour. My name is Mark. I'm developer advocate at Balena, based in Barcelona. So feel free to contact me at mark@balena.io. And just to don't spend more time, let me introduce my colleague Ayan, who is as well developer advocate, Tiger, who will do as well a presentation, and Alan, who will do the last but not least presentation today. So let's start with Tiger, with your application on balenaHub. All yours, if you want to talk about what you have balenified and published on the hub.
Cool. Hey, everybody. My name is Ty Sullivan-Knutson, and I am the founder of Qventra. Qventra is a passive monitoring for senior living enterprise solution. Basically, what we do is we place sensors into the residence of elderly and assisted living and memory care types of units. And what we do is we monitor for things like falls, incontinence, and infection using passive sensors. I think why our project today is applicable for the webinar is because at the core of it, we're using smart home types of technology in order to solve the use cases in a business-to-business type of setting. At the core of our technologies, we use a communication protocol called Zigbee. If you're familiar with LoRaWAN, Zigbee, Z-Wave, Thread, they all kind of operate in the 2.4 gigahertz spectrum. LoRaWAN doesn't, but the other ones do. And what it is really useful for is building out mesh networks of devices with a very large novelty of they run for 3 to sometimes 5 years on just coin cell batteries. That's a big deal when you don't want to be going over there and servicing these devices, these sensors. It's very much a set and forget without having to have a mains power supply. I found Balena pretty early on in regards to how to manage the fleets that we have deployed. Our fleets basically consist of, we started with Raspberry Pis, we've graduated to Intel NUCs, and we basically strap on a Zigbee radio in order to connect all of the smart home devices to our hubs. Today, I'm going to talk a little bit about the project that I published. It comes from 2 years of our work on how to set this all up from a robust perspective. I'll dive into a few of the containers and how that all works and how we use it. And then I'll relate it to how you can use this technology around your home or an office or a business or whatever you want to do to monitor things passively through the Zigbee communication protocol and have the entire stack to do so. So can I get some presentation rights? Let me see here. Let's see. There it is.
Sure.
Is everybody able to see my screen?
Yeah, I see your GitHub repo.
Yes. Cool. So this is my repo. That's our company right there, Qventra. You can visit us at qventra.io if you want to learn more about what we're doing. But the repo in general, it's based around this architecture. Oh, that doesn't look good. It's based around this architecture right here. So we position sensors throughout a unit. Most common in smart homes are things like contact sensors, motion sensors, smart switches, vibration sensors, you name it. There's a plethora of different devices out there that you're able to connect via Zigbee to a hub. In order to do so, and kind of the novelty here is the Zigbee to MQTT software, which takes the Zigbee payloads from these devices in an open source manner and allows you to manipulate them and then send it back to some sort of cloud infrastructure or home assistant or whatever it may be. You'll see a lot of this in Google Home or the Akara solution, but those are all very proprietary hubs. You don't have access to that data necessarily. This allows you to grab that data and you're able to manipulate it on your own in order to actualize the use cases that you're looking to do. So we take the data that comes from Zigbee to MQTT, we pass it over to Node-RED. From there, we manipulate payloads in the low code type of graphical user interface that Node-RED is famous for. we push that over to Mosquito, which is a MQTT broker. And then we push that out to AWS, who is our cloud partner here for further manipulation. And then we connect our front end application there. But this repo right here is the entire stack that you need to manipulate Zigbee devices in an open source manner and control all of that data for all of the payloads that are, or sensors that have been provisioned. So I'll go over here and just show you our balena dashboard and how this is one of our pilot sites. This is actually, I think right now, 25 beds, 25 units of information there. And you can see down here, we have the services running, our Mosquito MQTT hub. Right there is our Node-RED, a reverse proxy so we can get around to the graphical user interfaces, which I'll show here soon. And then our trusty and loyal Zigbee 2 MQTT. You can see the payloads coming in right now live as people are moving about, for instance, their bathrooms. We got a toilet flush right here. A button was pressed, a panic button, through their bed, bathroom, kitchen. So we monitor all of these payloads in real time, and then we push them over to a Node-RED instance where we're able to grab those payloads and do what we need to do with them. So they come in through this topic right here. You can see them kind of coming in over the right end. And then we push them to various functions for the types of sensors that they are. We got one for humidity, and the kitchen, the door, the fridge, the bedroom. We got incontinence, buttons. Over here is just some more logic in how we do it. But this, we grab all of the information from the payloads that come in and then push it out to our MQTT, and that heads over to AWS where we're able to go for further manipulation. The cool part, and really this is a huge project. I think it's got about 8,000 stars on GitHub right now. But there's a gentleman called Koenk who has developed this software in order for individuals to manipulate the devices that they have connected to Zigbee 2 MQTT. This is a really nice graphical user interface. Over here, you can see all of the sensors we have provisioned in this particular facility. It's all connected via a mesh network. I mean, how many do we have right now? 129 different devices clicking in real time. So we can go over here, we can drill down into very granular details as to what's going on with a particular sensor. So right there, there's a motion sensor that we have deployed in the unit 113. And then if you want to see like what the network looks like in real time, looks sort of like this. I ran a little network map earlier. We have some of these that need to be repaired. Again, this is one of our R&D locations, but you can see a lot of these are going strong with a lot of different devices connected to particular routers in each one of the rooms. I'm actually heading down there next week to provision some new devices and see how all that works. But this really all goes to show the stack and the power that is involved within this stack on GitHub that I've already published. You're able to connect smart home devices to a non-proprietary gateway, and you get to control the data and create technologies around the data that you generate. If anybody needs any help regarding this, I highly recommend you join or come on over to the Zigbee 2 MQTT Discord. I'm in there. The Home Assistant Discord is also very active. There's forums for both of these communities. And basically you go out, you buy Zigbee devices, pair it to your Zigbee to MQTT hub, and start pushing payloads to Node-RED or whatever sort of rules engine that you have, and start making that data really come to life on the application end. So that's all I have to present today. I'll continue to contribute to this resource, but it has really helped us, and it is the bedrock of how our product works in the enterprise and in the market today. So thank you, and I don't know if we're going to do questions now, but happy to answer any if they're here. So.
Oh, wow, that was amazing. Actually, yeah, I love that. Yeah, a lot of people is starting to use Node-RED as well to handle different things. And yeah, and then yes, as Ayana is mentioning on the chat, this sensor map was super amazing. So this is yeah, probably draw these type of charts and and graphs. It's really interesting. What did you use to draw that? It is out of the scope, but yeah, I'm still stuck.
So again, all of the code is available via that repo. I've kind of just stitched it all together. That's probably about 6 months of work. Anybody who deploys this on Balena, you're going to be 6 months ahead. Go over there and go ahead and connect your devices, connect it to Home Assistant, connect it to your own type of graphical user interface, and get building. Again, our use case was very much the senior living facilities here in America, but your use case can be completely different. I know Balena uses or has a customer called InFarm that does a very similar thing, where they control a bunch of plants and the nutritional value of the plants and the soil and whatnot, using very similar sensors and a very similar architecture to what we do, except our use case is in senior living. So I'm seeing a lot of growth out there right now in the smart home space. I mean, if you go over to Home Assistant, people have their entire houses automated, like smart home status, what you thought it was going to look like in 2000, where the lights turn on, music turns on, oven turns, everything is just automated. So really, the world is your oyster. If you're going B2B, pick a use case and just keep building. That's what we did in our case. But if you're just looking to set something up just around the house, highly recommend hooking this up to a Home Assistant, and you'll have the flexibility of Balena with a nice pre-built graphical user interface on Home Assistant. So best of luck to everybody who's building out there with this type of stuff. Feel free to reach out. I'll leave my email in the comments. But again, we wouldn't be here without Balena and the open source contributors for all of the softwares that we use today. So thank you all, and I'm happy to give back in any way that I can.
And Tiger, one question. So it's in the chat, but yeah, it was also on my mind. So if I'm a newbie and I don't have anything connected at home, so where people can start, or how tech people can start connecting things with Zigbee at home? What do you recommend?
I will post a link to Zigbee to MQTT. There is a guide at the top right called Getting Started. Follow that guide and you'll get started. And then I recommend you use the stack that I have there if you want to run this on Balena. If you're looking to scale, Balena is probably the only easy way for a newbie to get started like that. I'd also like to recommend a highly active Home Assistant community. And these guys are the pros at basically open sourcing everything that Google Nest has done, everything that Amazon is doing, and they make it all readily available from a graphical user interface on your mobile device, on a web device, you name it. So they have a lot of pre-built templates over there, and it's all about stitching everything together that fits your use case. So yeah, I see another comment over there, Grokbeer. Ty, can you speak more about the use of Node-RED and why you chose it? So there are a couple different, I don't even know what you would call that type of software, rules engine, I guess. I use Node-RED because I used to work at IBM. They had it in their open source community for a long time. I just know how to use it. I've used it for 5 years or so. There's other stuff out there called, there's one in Python, I forget what it's called Daemon something. And then for Zigbee, I mean, for Home Assistant, they have their own language as well to kind of use that rules engine. I personally think that Node-RED is the most extensible and flexible, but really any of the rules engine tools out there that work are going to work for your use case. Pick something you're comfortable with, pick a language you're comfortable with, and just like we all do, go out there and grab snippets from the web of people who have walked that path before you. Don't waste time doing something that's already been done. So plenty of resources out there for you to build your rules engine around the data that you're able to generate from these smart home sensors.
Yeah, that's, yeah. And it's very flexible, right? Node-RED, you can do whatever you want, and you have that. That's very cool. I check on the Zigbee to MQTT website, where there are like more than 2,000 devices compatible or supported from 300 different vendors. So yeah, I mean, go to the website that Tiger suggested. Yeah, go to supported devices, and I'm sure you can start connecting some of them there. More questions. Can we have the link of the communities in the chat? Yeah, you mentioned the Discord from the community, but I'm sure it's on the Yeah, it's on the Zigbee to MQTT, right? It's if you go to support, there is a link to Discord or GitHub. I'm sure these are the ones, right?
Yeah, and if you're just trying to get up and running, I mean, obviously first do a Google search. If you can't figure it out, come on over to Discord. I'm not going to tell you my screen name in there, but I'm in there quite a lot. I'm happy to help you out through that medium. If you want to pick my brain on business type stuff or how you can use this type of stack in order to launch some sort of B2B product, I'll drop my email in the chat. Otherwise, I really do think this is the way that everything is going for battery-powered smart home devices on the Zigbee to MQTT, and I think also in the home assistant community. These communities are all also working towards making devices and the gateways Matter compatible. Everything's moving to Matter. So again, these communities, open source, they're at the forefront in implementing this on all the radios necessary. So if you build on these platforms, you're building for the future. So come on in, come on down. Very friendly communities, really helpful communities. We all believe in open source. We all believe in helping each other. And that's why I'm extending myself today and further through the Discord as well as my email address. So please feel free to reach out, get involved, and let me know how I can help.
Yeah. Do you know if the name of Zigbee is going to disappear at some point with Matter or?
I don't think so. There's a few different Zigbee generations, I guess you would call it, 1.2, 3.0, and really it's just implementing a small firmware packet on the sensors. So the path is really easy to move forward, and then backwards compatibility is always going to be there, because if you look at the Matter spec, it's a lot of what the Zigbee cluster library is centered around. So I think there's going to be backwards compatibility from Zigbee to Matter, there and back from a long time, moving into the future. So,
okay. We have a question from Lucas. I see that in the repo, there are a lot of unencrypted passwords and MQTT certificates. So do you have any recommendation for unsecured passwords or unsecured networks on the repo, or you have any recommendation if anyone wants to put this on production?
Yeah, you're going to want to, I think exactly Lucas's suggestion, you're going to want to make your own certs, file up your own password. And the reason you need to do that is for Nginx, in order to access the web UIs that are associated. If you look at the repo, I show you how to tap the web UIs when you have it hosted via Balena. So when you tap those web UIs, it actually goes through Nginx. And every time I go through Nginx, it wants a username and a password. I set it with something trivial over there. You can see it at the bottom of the GitHub admin, password 881000X, capital XX. Go ahead and change that if you're going to use that in production, because I mean, it's probably better safe than sorry in this case. But yeah, good catch there, Lucas. I appreciate that. Yeah, but I'll hang around for another 5 minutes in the chat. Otherwise, thank you guys for having me. I really appreciate it.
Yeah, thanks for joining and accepting the invitation. It has been a pleasure to meet you finally.
Cheers. Yeah, well, we'll catch up after this. I'll send you an email. We should talk one-on-one. But thanks, everybody. I appreciate it.
Thanks, Tig. Lovely talking.
Thank you.
Adios.
Yeah, the Discord link, actually, yeah, as we mentioned before, yeah, let me put it on the chat, and then we move to the next. But it's, if you go to the Zigbee to MQTT website, let me put it again. There are all the links here, if I'm not wrong. So let me put it on the chat again. Yeah, or there is this invite. Yeah, sure. Or the invite works as well. But yeah, in case that you want to go to the GitHub repo or something else. All right, so let's keep going to the second speaker. Yeah, if you have questions, feel free to ask on the chat. But our second speaker is Ayan, and he has an application on balenaHub called ESP Home. So all yours. Let me know what is.
Yep. All right. Hi, everybody. My name is Ayan. I'm a developer advocate here at Balena. And today I'm going to be showing you a quick demo about creating your own smart Wi-Fi device and control it assistant. So I will try to keep it time boxed, but let's see how it goes. So I'm going to share my screen and let me know once you see it.
Yeah, you don't need to run. Take your time.
Okay. All right. Can you see my pretty lovely top-down camera here with the Raspberry Pi and some antennas? All right. Perfect. So this is the projects that we're going to be talking about today. Tig has mentioned a lot about Home Assistant, but basically Home Assistant is like a home automation server where you can put all your smart devices. The home automation industry is kind of like every vendor have their devices, their own cloud. You cannot control one vendor device with the application of other vendors, and that's where Home Assistant come into picture, where you can bring all your devices and control it from a central place. And as Tig mentions, it's completely open source. You can go and look at the code, you can modify it, you can add more features. So we're going to be talking about Home Assistant, and meanwhile, Mark can share the links. So we have two open fleets, and the open fleets you can join if you have a Raspberry Pi board. You can join the R64, and if you have Intel NUC, which is also very common board which people uses for Home Assistant, then you can join this fleet. If you're new to Open Fleet, you can just go to this page and you can click Get Started. You can add your Wi-Fi credentials and you can download the Balena OS, which when you flash or boot your Raspberry Pi, it will just boot into the home automation server, the Home Assistant. The other thing that I will be talking about in this demo is something called ESP Home. So ESP Home is also another project by same community that made Home Assistant. And using this, you can convert this device, which is an ESP8266 board, into a smart Wi-Fi device, and you can control it remotely over Home Assistant, which I'm going to be showing you. So I actually combined both of these projects into a single Docker Compose file, and I created this project. So over here, you can see my Balena project is running 3 containers. One is the Home Assistant. Other one is the MQTT, which is basically a message queue telemetry transport protocol based on publish subscribe model, which is de facto when it comes to communication and Internet of Things. And then we have ESP Home. So you can run these 3 into different devices, but since we are running Docker Compose and Balena, I am running them as 3 different containers. So this is all running, and I am going to be quickly showing you how it looks. So if you go to the IP address of my device on port 80, you will see that you will be presented with a onboarding screen of Home Assistant, and this is the first time you're going to see the screen when you are logging into the Home Assistant. So it's going to ask for your name. So I'm going to say, okay, my name is Zayan. I'm going to give it a very difficult password, so even I forget that after this talk. And then I'm going to create a new account. And over here, you can do something like what is your time zone. You can definitely change it later, but I'm just going to do quickly INR since I'm in India. And that's all the onboarding is needed. If you want to help grow the project, you can share the analytics, but we're going to skip that for now. And you can see that right over here, it identified that I have a Sonoff Zigbee dongle. So this is the Zigbee dongle, and as Tig mentioned, Zigbee is like one of the wireless mesh networking protocol, which enables small battery-powered devices to communicate with one another. And it's pretty common in home automation. For example, Philips Hue Smart Light, they work on Zigbee. A lot of battery-powered devices work on Zigbee, like this panic button over here. This is a coin cell operated device which runs on Zigbee. And this Home Assistant has already detected that I am running this Zigbee coordinator, and it's asking if you want to set it up. So I'm going to do that quickly. So it's going to quickly initiate the onboarding process, and what it's actually doing, it's actually sending out signal to all the Zigbee devices in my home network, and if it finds anybody, it's gonna put it in the Home Assistant. So we're gonna finish the setup. I won't be talking about Zigbee, but if I'll get time, I'll talk about the Zigbee in a bit. But today we're gonna be talking about Wi-Fi devices. So how do you create your own Wi-Fi smart devices? So there are different ways, but if you want to DIY your own Wi-Fi smart device, you can use something like this. This is ESP8266 board by Adafruit, and I'm going to convert it into a small Wi-Fi switch or Wi-Fi bulb. So let's see how you can do that. And that is where the ESP Home comes into picture. The beauty of this project is even if you have no prior programming knowledge, still you can able to do that because it's a no code or low code tool. So let's go to ESP Home, and I'm going to go to the same IP address of my device, but this one is running on port 6052. So over here, you are presented with a screen of ESP Home, and that is where you can add your new device. So I'm going to connect this device to my Raspberry Pi computer over here. And the first thing I'm gonna do, I'm gonna click to new device, and I'm gonna click continue. Over here, you can see there are different fields like what do you want to call this device. I'm gonna call this bulb because it's gonna act as a bulb. So assume that you buy a smart bulb, and inside of that there is this kind of board there, but we are DIYing, so we're gonna keep it simple. Over here, you can give the Wi-Fi credentials to which you want to connect. I'm gonna give to my home router, and I'm gonna click next. And then it's gonna ask which board is this. So you can add different boards here, ESP32, ESP8266, but I'm gonna pick a specific board. So this one is by Adafruit, called Adafruit Huza ESP8266. So I'm gonna select that. And this is the device that has been created. And now if you go here and if you look at the edit section, you can see that there are all sort of things done for you, like what is the name of the device, what is the board, and this is for over there updates. So once you flash the firmware on this, then you can actually disconnect it from this Raspberry Pi. It can stay on your network connected, and you can do all sort of over there upgrades using this password. And this is the encryption key. Basically, Home Assistant and this device will communicate over Wi-Fi, but it's going to be encrypted. But you will see that there is no code that is telling that which pin to on and off when a signal is being sent from Home Assistant. And that's where we will go to the ESP Home website, and we're gonna look for something called switch. So you can see there are different components, like a light component, like a button component. So whatever thing you want to emulate, you can do that. So I'm gonna click on the switch component, and I'm gonna use GPIO, because what I'm going to do, I'm gonna use one of the GPIO of this device, and I'm going to convert them. So this is a sort of thing that is gonna come up. So whenever I press this toggle, it should turn on. So I'm gonna take this example, and I'm gonna paste that into this file on my ESP Home. So I know that there is LED connected to pin number 0 of my board. So I'm gonna use pin 0 for this demo. And instead of calling this living room dehumidifier, I'm gonna call it bulb just for the sake of simplicity. And I'm gonna click save. I'm gonna click close. So this is basically a YAML format. If you could look from the look of it. So what you could do is you could actually click and you can validate that everything in YAML is correct before flashing it. Once it's done, you can actually click and you can click install. And what it's gonna do, it's gonna compile this into a binary file, and it's gonna flash that ESP board. So there is this beautiful thing here. You can do that completely wirelessly, but since this device is not already connected, we're gonna do it using the computer over which it is plugged in, and it is plugged into my Raspberry Pi board. So I'm gonna use that, and I'm gonna say, okay, this is the board that I want to flash. It's gonna take some time to build and flash, but that's only for the first time. Once you do the first build over there, the iterative build are relatively quicker and smaller. So it's gonna be downloading a tool chain, then it's gonna cross compile all those libraries, and then it's gonna flash the firmware. But once it's flashed, we could see it and we could add it into the Home Assistant dashboard that we just created. So I'm just gonna wait. Meanwhile, we can explore the ESP Home project. So over here, you can see that there are different things that you can do. You can do air quality, you can do Bluetooth low energy as well. You can do light sensing, thermocouples, temperature, things like that. You can do fan. So do explore this page. I'm gonna post that in the chat window as well. Okay, I don't see a chat window, but I'll post it after this talk. So yeah, that's like a very nominal low-code tool to build your own Wi-Fi smart devices. And one great thing is with the integration of Home Assistant, since both of this project is made by a same community, as soon as this device comes online, you can see it's gonna show up over here. So we're gonna play the demo gods, and we hope everything goes as we are expecting it to be. In the meanwhile, what I can show you over here, I have a Zigbee bulb. So let's see, while it's compiling, can we add the Zigbee bulb as well to our Home Assistant? So this is a Philips Hue Zigbee bulb. And let's see if we can also add that. So I'm gonna go back to Home Assistant. I'm gonna go back to settings, device and services, and the son of Zigbee, the Zigbee page where it's there. So this is a ZHA Zigbee Home Automation Library. And I can click devices, and I can click add device. So hopefully this Home Assistant Zigbee Home Automation Library gonna sense that, okay, it does. So you can see there is this Philips light bulb over here. So I'm going to name it, I'm going to say it light 1, and I'm going to add it to my bedroom. So this device is ready to use. Now let's see if we can control them. So I'm going to go here, and looks like it actually picked the other light, if you can see in the back. So it actually picked the other light. But you can see I'm going to change that. I'm going to add it to the dashboard, take control. I'm going to add a new card by entity, and I'm going to go light 1. And I can actually pick a different card. And this is the card which could also help me change the color. So I'm going to change that. And you can see over the back, there is a Zigbee bulb, and I can actually turn it on. I can turn it off. I can change the color. So currently it's pink. I can do it white. I can do it green. I can decrease the brightness. I hope you were able to see that. So it identifies the Zigbee device on my home network, and it added it. And similarly, I can add this bulb on my desk as well. But let's see what's the status of the ESP home compilation. It's still compiling, so we're gonna wait a couple of minutes more. In the meanwhile, I'm gonna go back and try to find this new bulb, and looks like this bulb is also added. So what we could do, we could add another card by entity. Let's see if I can add this one and add this one. Continue, pick a different card, this one, save. All right, so now you can see that over here, you can see that I'm also able to control this light. So I'm going to turn it off. I'm going to turn it on. I can also change the color. I can change the brightness. I can do some effects as well, like color loop. So this is about the Zigbee device, and you can see how easy it is to do that with the Home Assistant. Now back to ESP Home, where it's still compiling. As I mentioned, on the first run, it could take some time, but once the first run is complete, it's much simpler because it's gonna take deltas for compilation. But yeah, as you can see, you can customize your dashboard. You can do different sort of things, and you can actually make this sort of bulb on your own, and you can also add some temperature sensors like I did over here. So if you could look over here, you can see there is this custom board with the temperature and humidity sensor, and there is this new pixel LED light. So this is the demo which I could also show later on, maybe after Alan's talk. But all right, looks like the compilation has been successful on the ESP Home, and it's gone. It's okay. So this one is connected to my Wi-Fi. You can see it's got an IP address. Let's copy this IP address. I hope we don't need that. But now what we're gonna do, we're gonna add this device. Okay, where's the top-down camera? There it is. We're gonna add this device to our Home Assistant dashboard. So I'm gonna go back to my Home Assistant dashboard. So generally speaking, whenever a new ESP Home device is initiated in your network, it shows here as a notification. But because this is a demo and demo gods are not very kind always, it's not there. So what we could do is we could manually add that. So for that, go to settings, go to devices and services, and click on add new integration and search for ESP Home. And over here, you can add the IP address that your new device has got, and you can click submit. And over here, you can add the encryption key. As I showed you, the encryption key is this one. This is the key that is used to encrypt messages between Home Assistant and your new created Wi-Fi device. So let's gonna add that. And you can see that bulb has been added. I'm gonna add it to bedroom, and I'm gonna click finish. So now I can go back, I can add a new card, and I can see my bulb is here. And I'm gonna add to dashboard. Now I want you to look very carefully to this camera as well as this button. So whenever I toggle this button, you can see the small LED over here. It's changing the state, and it's different. Like when I'm toggling it off, it's getting on. That you can fix by going back to ESP Home and added another line called inverted colon true. So I'm gonna click save. I'm gonna click install using this, and you will look that this time it's gonna compile much faster. So what we actually did, we created our own DIY Wi-Fi device using ESP8266 board, and without writing any code, we were able to control it via Home Assistant. So you can see this time the compilation was much faster. And once it's compiled, it's gonna connect back to my Wi-Fi, and I don't have to add this again and again. It's gonna stay added, but let's wait for it to come online and connect to my Wi-Fi network. All right, it's online. I'm gonna go back, and this time you can see that it's actually matched. Okay, it's not online yet. Let's give it another second. Okay, it's online. This time you can see that it's actually matching the toggle on my dashboard. So turning on and turning off, turning on and turning off. And you can add a small relay in front of it, and you can control your home appliances. So yep, that was a small demo of how you can create a Wi-Fi device using ESP Home and control it via Home Assistant. And I also showed you how to do that with the Zigbee. So yeah, that was all for my demo. Meanwhile, I'm gonna set up more demos. So if we have time at the end, I can show you. But yeah, that was all for today. Thank you.
Awesome, Ayan. Thank you very much for the demo. Questions for Ayan? Feel free to ask. Ayan, what you show actually, it's you show 3 containers on your device. I'm not sure if it's a Raspberry Pi or an x86 device.
Yep.
What you have.
It's a Raspberry Pi 4.
So what did you have? You had Home Assistant, ESP Home, and what else did you have?
Yes, I'm gonna show that again. So I actually had 3 things. One is the Home Assistant, one is MQTT Broker, and one is ESP Home. So MQTT Broker is similarly, it's just a broker which works on publish subscribe model, and people who are into IoT, they are much familiar with MQTT. So you can run it completely in a different cloud service or on another device, but I chose to run it on same device because it's a very lightweight container. So if you are being part of my open fleets, so it gives you 2 things actually. It gives you Home Assistant, and it also gives you Mosquitto MQTT Broker. So these are the 3 containers that are running on my device.
Thank you, Ian. Questions? No, there are no questions. Yeah, there are. So Jorge just asked about if the recording will be available. Yes, it will be available on YouTube during the next days. If there are no more questions, maybe we can jump to Alan and get the questions at the end of Alan's presentation. What do you think?
Yep, sounds great.
Makes sense. Oh, wait, there is a question.
Okay, so Lucas is asking, is Raspberry Pi 3 enough to run all these containers in a small device? Actually, yes. So you can actually run Raspberry Pi. You can actually run all these containers in a Raspberry Pi 3. But the thing with Home Assistant is it's number one, very addictive, and number one, it's very scalable. So you're gonna keep adding more and more devices. You're gonna keep adding more and more automations. And then you quickly outgrow yourself, and you will find that even Raspberry Pi 4 is not enough. And that's how people start. So I would recommend, if you are running Home Assistant, Raspberry Pi is a great way to get started with, but over time you will quickly find yourself outgrowing the Pi, and that's where Intel NUC comes into picture. Or you can run the same thing into your old laptops as balena devices. So, but yes, Raspberry Pi 3 is enough if you want to experiment with this.
Yeah, that's great. We're gonna see what Alan is using to run Home Assistant. Actually, I'm not sure what prehistorical device does he use. And I don't want to do any spoiler. Sorry.
No, that's okay. Hey everyone, I'm Alan. I'm a hardware hacker here at Balena, which means I get to create a lot of cool projects on the Balena platform to show off how it works and all of its strengths. And just for the full disclosure, I actually am not running my Home Assistant on Balena because I did graduate to, and it would work, great on Balena, but I started my Home Assistant years ago before I was using Balena, and I'm on a huge x86 machine running Docker. But I do encourage you to start using it on a Pi using Balena because it's great. And we do have a really great starter example also in our Balena Labs GitHub repo. There's just a really great, very basic starter repo on how to use Home Assistant on Balena, and I think we'll be able to add a link to that as well. But for
Sure.
today, I'm going to start by going over here, and you'll have
What's
to pardon
that?
me. I'm on my iPad today, but as I said, I'm not using my Home Assistant on Balena, but I do have a number of Balena powered projects that are feeding my Home Assistant. Excuse me, and this is one of them right here. This is a wall mounted 7-inch Pi touchscreen. Let me get a better angle here so there's no reflection. And I'm a big fan of dashboards. And what I really wanted was a huge wall mounted dashboard, but it wasn't in the cards for the house here. It was not appreciated to have a 32-inch screen running Home Assistant dashboard. So I reduced it all to this tiny 7-inch screen, and it's custom mounted here. And this is a Pi 3B Plus behind the scenes, excuse me, running the PoE hat. So we just have one wire going to this. And this is actually running Balena, and this is using the browser block. So that's another great Balena project that I recommend. This whole screen is just using one container where you specify the URL, which is the URL of my HA dashboard page. And that's part of app daemon, which is also mentioned in that repo that I talked about. And I'm going to swing around here just so you can get a better look at this. Let me flip my camera. Okay.
Oh, cool.
So yeah. So since it's a touch screen and the browser block supports this, I can just move through the different screens that I've placed on here. And I'll
Did
get
you pray
to
to the demigod? So yeah.
Yeah.
So
I mean, the funny thing is that for most people, you interact with Home Assistant on maybe a tablet or you use an app or a web page, but I do almost all my Home Assistant just from this little panel right here, which makes it really easy. And this is my main screen that just tells me if it's okay to leave the house based on a lot of different criteria. And one of them is that no water's running. You don't want to leave the house if your water's running. So I will talk about how this whole water thing works in a minute. There's just one or two other quick things I want to mention here. I'm also monitoring power, and right now I'm using 4,500 watts of electricity, which is pretty terrible, actually. I've used 27 kilowatt hours today so far. And the front door is locked, as you can see. But let me go into water a little more here. We can see real-time water flow, real-time energy usage, and also the costs. And you'll have to pardon the text here. It's always a work in progress. I'm always tinkering with this. This also is a Grafana graph that shows the last 24 hours of power usage, so I can get an idea of how I'm doing. One more screen here that I want to just show that's Balena related. You'll notice these temperature readings around the house. I'm actually using another Balena project to feed sensor readings from around the house into Home Assistant from using MQTT. And that's our sensor block, which is available on the hub, and our simple sensor program, which allows us to run the sensor block on a Pi 0W with a sensor. And I'm actually going to show that off in a second. And I've also wired in sensors into most of my major components like the HVAC system and so forth. But going back to water real quick, because I know that's the main point of this presentation. So I'm going to go downstairs to the equipment area to actually show how I'm doing the water flow and give a quick demo of that. So let me flip the camera again. Going to take a walk into the basement that few people get to see.
Yeah, be careful.
Welcome to my messy basement where all the equipment is. We'll go deep down into the ground where it's about 15 degrees cooler down here. And I'm going to flip the camera again. And we go to the water main. This is the water main that comes into the house. And this is the meter that I've added into the water main. This was not here. This is not part of the utility. I added this myself. And it's just a basic water meter, but what it does provide is a pulsed output through these wires. And that pulse every pulse that it outputs represents about 9 ounces of water flowing through the system from, you know, bottom to top into the house. Now, there are many different kinds of meters that you can get, even Z-Wave meters that you could immediately just integrate into Home Assistant. But having the raw pulses gives you, you know, the complete control, so you can do really whatever you want. So what have I done with these pulses? Well, pulses go up through these wires all the way across the ceiling to the main panel area, down to this lowly ancient Pi that's been running here for years. And it goes into the GPIO pins, and there are containers running on here. This is not yet balenified, but it does use containers. And they're counting the pulses, creating readings out of that in ounces and gallons, and sending that to Home Assistant via MQTT. And in addition, there's a container running on here that is also calculating the utility costs. And that has a web interface where I can enter my utility bills every month. And just above that is another Pi. This is a newer Pi, but it has a big header hat on it. And that's connected to sensors all over the house. So that's just using GPIO. I'll show off the container control panel that I made for those in a second, but I thought I would do a quick demo of just how responsive this water meter is. So let me go over here, and I'm going to attempt this screen sharing on an iPad. 1 second here. If it'll let me share my screen. Yep, start broadcast. Okay, and we'll watch the meter in real time. So let's go down here. So this is the same dashboard that's running upstairs on that device that you saw on the wall. And pay close attention to the water flow as I turn on this sink. And let's hope that this browser is connected and working, because we should pretty quickly see the water flow. I may have to refresh this browser because it's just been sitting here for a while. So let me do that. And there we go. So now it's registering, and we have a little bit of flow here. Let's really crank it up. Whoa, and see what happens.
Careful.
There it's going. Yep, there we go. 19 ounces per second. That's a lot of water. And you'll probably see the water cost jump up while we do this. And I'm going to turn that off now. That demo probably cost me 10 cents right there, but it was well worth it. So let's go back over here for a second. And I'm going to go to this next screen that shows the temperature. Now I can't actually see what my camera is seeing, but I hope you can see this device right here. This is a Raspberry Pi 0W that's running that simple sensor, and it has a BME 280 connected to it. You can see it's just sitting here on its own using wireless. And that is what's feeding the basement temperature and humidity that you see on the screen right now. So it's a $10 Pi 0W and maybe a $10 sensor. And you can place these throughout the house, and using this right here, this project on Balena, it's just transforming the values from that, sending it via MQTT to Home Assistant. And then we can get that data into Home Assistant. So that's another nice, easy starter project for getting data into Home Assistant via MQTT. And I mentioned I would also show the water meter. So here's the, for this water meter that's running here, this is the web browser page that I made. This is also available where you can actually just set a bunch of stuff. I'm not going to scroll too far because all of my, all of my password settings are in here. Not that it really matters, but I just to be safe. But you can set all the different things that you want. And then also with this GPIO settings, this is for the other device, and this is also available in a repo, so that you can send all of these different sensors as well to Home Assistant. And I think that is it for this. I'm going to stop this and try to switch my camera back to me. And I think I'll take it upstairs to the back to that screen, unless there's questions as far as what everyone saw in here.
Wow, that was amazing. Thanks for that demo, Alan.
Thank you.
Do we have questions here? Okay. Yep, put in the chat. People need a lot brochure for this project. Yes, maybe we can use the recording later onwards. You can watch it at your own pace. But yeah, we'll also add all the links to the projects when we put this recording on the YouTube, so you can check it out. The balenaHub, and even if we have some blogs about this as well, so we're gonna put that as well.
We have a
Now I'm
question
waiting.
from.
If
Sorry.
Alan has a solar power setup. Alan, do you have a solar power setup?
I don't have solar power. It's on my list. I have a small off-grid system just for emergencies, but I don't have solar feeding the house yet.
Yet. We have a question from Kirk. Is asking what Balena versions are you running on your old Raspberry Pis? Well, just to clarify, that was not a Balena Raspberry Pi, right? Because
Yeah,
he
that
says
old
that
one.
he cannot
Right,
get
yeah.
to work the old on his old Raspberry Pi. So I don't know, what suggestion do you have for developers from the community who have old Raspberry Pis and they want to run this type of projects?
Well, I mean, that Pi, I believe, is running Raspbian Lite or Raspberry Pi OS Lite, I guess it's called now. It's an older version. I think I put that together in 2017, and I don't think I've really changed it much since then. So I guess if you're really desperate, you could probably use an old version of Raspbian Lite. I did install Docker on there, but I haven't tried putting balena on the device like that. I'm not sure we would support it, but it's worth a shot. But there are ways to utilize those. I think the best thing maybe is to buy, it would be to get a Raspberry Pi 02W. They're cheap enough and powerful enough, if you can find them though. That's of course the biggest problem. And we certainly support those, and those I would like to replace everything with Pi 02Ws, but availability is the biggest issue there.
Yeah, but I see your philosophy that if something works, you don't touch it, right? This is what you do, or
well,
or
it's
okay
time to
for you
upgrade. No, I should. I need to upgrade. And like I said, I'm going to convert all of those to running balena because they're already running containers now. So it makes perfect sense. It's so much easier to run containers on balena. So that's what I want to do.
More questions for Anne, please, or for Jan, or for whatever question you have related with home connected devices.
Actually, I had a question. I typed it also. How long did it take for you to put it all together, the whole setup, everything in your house?
Well, I mean, I guess I started about 10 years ago, but that's for mostly stuff that I didn't show. For the stuff that I did show, I think that all started same time I mentioned, around 2017 is when I really started with Home Assistant. And then 2018, 2019 is when I added actually a bunch of Z-Wave equipment. And then the water meter was about 2018 or 2019. So yeah, it takes time, especially, you know, in small increments. It's not an all at once thing. It's a forever project, right?
Yep, absolutely. Yeah, as I mentioned that you slowly outgrow the things that you want to add because it's really addictive. And I think Alan runs most of the devices on Z-Wave, while I use a lot of Zigbee based devices. So they are pretty much same. You can also, you know, interchange them, not the devices, but yes, I would recommend pick one and stick with one. So yes, and I'm quickly gonna share and show one last thing that I promised in one of my videos, and I hope people will not use that against me. So do you see my dashboard?
Yeah, I do.
Okay, so I wanted to show something that when you bring a lot of devices into the Home Assistant, what you can do is some sort of automations. So this is the automation hub, and I have set up some of my home automation over here. For example, whenever I'm having a video call, this is the small button that I have kept. It's a Zigbee based, and if I press it, once there are some lights over here that that can turn on, that can turn off depending on this, and all these things you can achieve in this automation and scene. So you can see that I can also create a new automation. I can use Blueprint. So I can show you one of them. So I'm going to press it once. Okay, it's nothing happening because it's a demo, and demo tends to fail all the time. So let's see, I'm going to refresh it one more time. Okay, it's not working. So I'm going to, okay, it actually works. So you could see I pressed it and it turns on. And if I press it again, it should turn off. Okay, it's not cooperating. Anyway, so this is something that I wanted to show, that automations are there that you can utilize. And so you can see, you can customize your dashboard. And this is entirely my office running on Home Assistant. I can, turn on the lights, turn off the lights from here. And you can also do groups. For example, if you have a couple of bulbs, you can add a group over here and you can turn it all together. And you can see this is the cove lights, the blue one over here. And this is the main lights. Yeah, so it's not very responsive as of now, but you get the idea. So it's pretty much scalable. It's all open source. It's all community driven. And if you want to contribute to it, feel welcome. It's a very good community to be part of it. And these were all the projects on balenaHub that we wanted to show today. So I'm gonna give it back to Mark, and we can talk about the next meetup maybe.
Yeah, sure. Well, we have one question that actually Alan replied on the chat, but yeah, actually Aran asked, do you know, oops, something pop up. Do you know what sort of energy your setup uses? I see household white energy usage. How much of it is the system? Did you, yeah, well, Alan actually replied on the chat, but I don't know, Alan, if you want to give more information.
Well, I think you saw the unfortunate 3,400 watts or so being used right now. Most of that's air conditioning right at the moment. It's pretty hot here now, and it's a pretty big air conditioning unit. But the home automation itself is only about 25 watts continuous, and that includes the server that's running Home Assistant. Sometimes it's a little bit more. But then there's also all of the networking, Plex servers, cameras, security cameras, and that can run closer to 100 watts continuous with all that.
Okay, makes sense. Yeah, I think you need some solar panels if you have the possibility.
I'm hoping to use solar panels to lessen that. I don't like the footprint. That dashboard that you saw actually also calculates CO2 equivalency so that I can see how much I'm throwing back into the environment. And part of even the water metering is also for conservation purposes as well. So there is actual use for this. I need to actually use it though.
All right. So yeah, I had a lot of fun during this the last 60 minutes. That was great. Thank you very much, Tiger, Ayan, and Alan, for sharing your amazing configurations of Home Assistant. Actually, Ayan just published on the chat that the next meetup registration link, which will happen Tuesday, 26th of July, similar time, and it's going to be the fourth meetup. It's going to talk about the citizen science projects that you can use, and they are available and open source on balenaHub. So we are looking forward to meet you all again. And yeah, if you have any question, you still have time on the chat, or you can find us on the regular channels on the forums at balena.io. or by email, Twitter, etc. So thank you very much to everyone for coming, and see you at the next meetup.